Up to this point, all of our equations have included standard arithmetic operations, such as division, multiplication, addition, and subtraction. Now, many real-world calculations involve exponential values, in which numbers are raised by a specific power.
For example, we know that 3 times 3 is 9. This is the same thing as 3 to the power of 2, or 3 squared. Similarly, 3 times 3 times 3 is 27. And that's the same thing as 3 to the power of 3, or 3 cubed. This applies to any number. So for example, to find 4 squared, we just multiply 4 by itself. We can also perform calculations in the opposite direction to find radicals or roots. For example, the square root of 16 is the number which, when multiplied with itself, results in 16, which, as we already know, is 4. You can find the root of any non-negative number, but numbers less than 0 can't have a root, because you can't multiply any number by itself and get a negative result. A positive times a positive is always positive, as is a negative times a negative. Now, consider this. X in this case is the power to which we need to raise 4 in order to get the result 16. We call this kind of calculation a logarithm. And in this case, we're looking for log 4 of 16, which is 2, because 4 to the power of 2, in other words squared, is 16. Let's take a look at a few rules for working with exponential values. First of all, when we add terms of the same power, we just need to add the coefficients. So x squared is just shorthand for 1x squared, and when we add that to 3x squared, we get 4x squared. So what about multiplication? Well, to multiply exponentials, you just multiply the coefficients as you normally would, and then add the exponents. So to calculate 2x cubed times 4x squared, well, 2 times 4 is 8, and 3 plus 2 is 5, so we get 8x to the power of 5. Division is the opposite of multiplication. So to divide one exponential by another, just divide the coefficients and subtract the exponents. In this case, 6 divided by 3 is 2, and 5 minus 2 is 3, so our result is 2x to the third power.